Imagine throwing something, not just once, but every single time it gracefully arcs back to you. Imagine throwing something, not just once, but every single time it gracefully arcs back to you. For millennia, cultures across the globe have understood this unique principle, crafting the iconic boomerang. It isn't magic. It's a brilliant dance of physics, honed by ancient hands and perfected by the invisible forces of the air. At its heart, the boomerang works much like an airplane wing. Each arm isn't just a flat piece of wood, it's an airfoil. As air flows over its curved upper surface and flatter bottom, a pressure difference is created. This difference generates lift, the same fundamental force that keeps a jumbo jet soaring thousands of feet up. But a boomerang has multiple airfoils, typically 2 or 3, arranged radially. And here's where it gets clever. They're not symmetrical. One side is more curved, designed to maximize that lift. When you throw it horizontally, spinning rapidly, each arm cuts through the air, constantly generating upward force. Now, the real magic, or rather, the real physics, happens with the spin. A well-thrown boomerang doesn't just fly forward. It rotates incredibly fast, often hundreds of revolutions per minute. This rapid rotation, combined with its forward momentum, creates a fascinating aerodynamic phenomenon called aerodynamic precession. Think of it this way: as the boomerang flies, one arm is always moving with the direction of the throw, speeding up its passage through the air. The other arm, however, is moving against the direction of the throw, relatively slowing down. This creates uneven lift. The forward-moving arm generates significantly more lift than the backward-moving arm. This difference in lift doesn't just make it wobble. Because the boomerang is spinning, that greater lift isn't felt straight up. Instead, thanks to gyroscopic precession, the same principle that keeps a spinning top upright, this unbalanced upward force acts 90 degrees ahead in the direction of rotation. It causes the entire boomerang to tilt, slowly rotating from its initial horizontal plane. As the boomerang tilts, its lift vector, which was initially pointing mostly upwards, begins to point inwards, horizontally. So, instead of simply flying forward and falling, it's constantly being pulled into a wide, graceful curve. If thrown correctly, with enough spin and the right angle, that curve brings it full circle, right back to the hand that launched it. What a marvel, isn't it? An object designed thousands of years ago, embodying sophisticated aerodynamic principles that took modern science centuries to fully articulate. The returning boomerang isn't just a toy or a tool. It's a beautiful, tangible demonstration of how deeply intertwined our world is with the invisible, yet powerful, laws of physics. If you've ever wondered what other everyday objects hold surprising scientific secrets, join us next time.